So we've taken a while and looked at arithmetic sequences and arithmetic series. Now we're going to take a look at geometric sequences and geometric series. Okay, so we're going to start today with geometric sequences. So what's the difference? All right, the difference is that in an arithmetic sequence, you're looking for a common difference. Okay, in a geometric sequence, you're looking for a common ratio. So a geometric sequence is a sequence in which the ratio between any term and the previous term is constant. Okay, or another way to say that is that you multiply by a constant, so constant meaning something that's always the same, which is called the common ratio. There's no R at the end of that word. Wow. Yep. Okay, common ratio, spelled it wrong, all right, which we use the term R for. To get from one term to the next. So with an arithmetic sequence, you're adding to go between terms. With a geometric sequence, you're multiplying to go to between terms. All right, so let's see if we can build a formula for this similar to what we did with the arithmetic ones. So let's look at this example right here. We want to figure out the 10th term of this sequence. All right, so let's play around with it a little bit. So I've got this sequence, all right, it's 2, 6, 18, 54. So it should be pretty easy to see that to go from here to here, I'm multiplying by 3. From here to here, I'm multiplying by 3. From here to here, I'm multiplying by 3, right? Okay, so much like with the arithmetic sequences, if I want to figure out how could I jump straight from here to here, so this would be a sub 1, a sub 2, a sub 3, a sub 4. So to get to a sub 4 from a sub 1, what am I doing? Well, I have to multiply by 3, right? Multiplying that by 3. And how many times? Well, 3 times, right? The distance between these two numbers. So the distance between 4 and 1 is 3. So that's how many times I'm multiplying, right? So I'm multiplying that first term by 3, and I'm doing it 4 minus 1 times. Okay? If I wanted to figure out, say, the 6th term, right? And I want to figure out what that is, well, I'd say, okay, well, to get to the 6th term, starting from a sub 1, I'd have to multiply it by 3. And how many times? Well, we're just counting the gaps between these, right? So I had to do it 1, 2, 3 times, and then another time and another time. So 5 different times. It's 6 minus 1. Okay? So the idea behind this formula is very, very similar to what we do with an arithmetic one. It's just instead of adding, we're multiplying. Okay? So if I want to figure out the 10th term of this sequence, all that I'd say is, okay, well, to get to the 10th term, I start with the first term. Our common ratio we said was 3. I have to multiply it by 3, 10 minus 1 times. Okay, and then from this, I can just very easily pull out that a sub 1 is 2, so I'm multiplying it 2 times 3 to the 9th. So I'm going to grab my handy dandy calculator because I definitely can't do that in my head. So 3 to the 9th times 2 is this lovely big number, so 39,366 is the 10th term in this sequence. Okay, great. So let's go back and fill in what our generic formula is. So our generic formula is to find any given term in the sequence, start with the first term, and multiply it by your common ratio, n minus 1 times. Okay, and just like with arithmetic sequences, you don't necessarily have to use the first and the last term. You could start with the 5th term and the 12th term, right? And then you would just make it 12 minus 5 up in your exponent, okay? All right, so let's take a look at this example. We want to find a sub 15 in the sequence. This is just another way of saying instead of saying the 10th term, we're looking at the 15th term. So to find the 15th term, right, I would start with the first term and multiply by the common ratio 15 minus 1 times. So to find a sub 15, my first term I can see is 3. Common ratio looks like we're multiplying by 3. We're raising that to the 14th power. So 3 to the 14th power times 3. You could have also just done 3 to the 15th power, right? Because if you have 14 threes, you multiply by another 3, that's 15 threes, right? And it works out to this very large number. So about 14 million. So hopefully you're already noticing, and this should make sense, geometric sequences get bigger way faster than arithmetic ones do. Okay, so they are definitely growing much bigger. All right, this one, we have the first term, we have the common ratio, we want to find the sixth term. Well, to get to the sixth term from the first term, I'm going to multiply by my common ratio, 6 minus 1 times. So a sub 6 is going to be 12 times 2/3 to the 5th power. Okay. When you put this in your calculator, make sure that you use parentheses around the 2/3, right? Because your calculator does order of operations whether you want it to or not. If you just do 2/3 to the 5th, it says, oh, exponents come before division, and it's going to give you a different number. Okay, so make sure that you use parentheses around your 2/3, and then I'm going to multiply that by 12. And that is that number. Okay, now since this one is in fractions, you want to try to give your answer in fractions. So remember, go to your math menu, and that very top option will change things into fractions for you. Okay, so a sub 6 is 128 over 81. All right, this one, we want to find a formula for this particular sequence. So I can see, I know what the first term is, right? And I can pretty easily pull out my common ratio is 4. So my rule would be to find any given term in the sequence, start with the first term, multiply by my common ratio, n minus 1 times, right? And since I want a formula, I want a sub n and n to be variables in my equation. So I do want to plug in the first term as 2. I do want to plug in the common ratio as 4. But that's it. That's how that would look. Okay, so that's how you write a rule. So you can kind of see, I honestly sometimes feel like the geometric ones are a little bit simpler. You get bigger numbers, but they tend to just, I don't know, sometimes be a little bit easier. All right, now this last one down here. So this is an example where we aren't starting with the first term. So there's a couple of different things that I want to focus on here. One is I want to look at, well, what happens when you don't start with the first term? And then 2, I want to talk to you about kind of an ambiguous case that can come up. Okay, so don't tune this one out yet just because it's last. So looking at this guy, we've got the 6th term and the 8th term. We want to find the common ratio and the starting value. Okay, well, what can I build using these two? I know that to get to the 8th term from the 6th term, I'd have to multiply by the common ratio 8 minus 6 times, right? The distance between those two. So I can use this to figure out what r is, right? So a sub 8 was 5, a sub 6 is 20. The common ratio is the thing that I don't know, and 8 minus 6 is 2, right? So divide both sides by 20. 5 divided by 20 is a 4th. So when I square root both sides, I'm going to get r equals, be careful, positive or negative 1/2. Okay, so my r value is positive or negative 1/2. It could be either, right? Think about it. If you start with 20 and you're going to 5, if I multiply by 1/2, you'd get to 10. Multiply by 1/2 again, you'd get to 5. But if you multiply by negative 1/2, you're going to get to negative 10. And then if you multiply that by negative 1/2, you're going to get to positive 5. Okay, so either one of those could be your r value. So now when I go to figure out what my A1 value is, it's going to depend. So we're going to have to do this as 2 different cases. First of all, we're going to have to say, well, what happens if r equals 1/2? Okay, well, in that case, I'd say, well, to get to, you can use either one. I think I'll use a sub 6. So to get to a sub 6 from a sub 1, multiply by your common ratio, 6 minus 1 times. I know this is 20. I don't know this. That's what I'm looking for. We said we're going to use positive 1/2 for r, and we're raising that to the 5th power, right? So I'm doing 1/2 raised to the 5th power, and then I need to do 20 divided by that number. So 640. Okay. So if our R value is 1/2, then our A value, A sub 1, is 640. So if R equals 1/2, then A sub 1 is 640. Great. All right. Case number 2, what if R is equal to -1/2? It's going to be pretty similar. I'm still going to do the same thing from the 6th term, or to the 6th term from the 1st. Multiply by your common ratio 6 minus 1 times. That's still 20. I'm still looking for this, but now we're using -1/2 to the 5th power. Okay, again, be careful here. You want to do, if you're doing parentheses, I mean, you could just do -0.5. It's probably easier. But if you did have a fraction that you need to put in, make sure that you put it in parentheses when you raise it to the 5th, okay, to make sure that you're getting the right answer. It's not going to be as obvious with this one because the answer is negative, but we've talked in the past about how whether the negative is inside parentheses or outside parentheses makes a difference on the order of operations. Okay, so just be careful about that. All right, so we're going to raise that to the 5th power, and then I need to divide 20 by that number, and we get -640, right, which should make sense. Okay, so if our R value is -1/2, then A sub 1 is equal to -640. So depending on what you get for your R value, you could have different potential starting numbers. Okay. Now that won't always happen because, like, if you think about it, with either one of these cases, the next term in the sequence will be positive, right? So if this had just been shifted off by 1, they could have started with the same number and then just got different answers later on. Okay, so it's not always necessarily going to be different numbers for A sub 1 if the R values are different, but sometimes it will be. And sometimes it'll be a little bit more dramatically different than just having a sign change. Okay, so that's just something you want to make sure you watch out for. Okay, so pretty easy formula. Okay, don't forget, like we did here, you can always modify the formula. It doesn't always have to be from A sub 1 to A sub n. It could be between any two given A values, okay? So just watch out for that and you should be pretty good. Geometric sequences, again, geometric is when you're multiplying by a constant number. Arithmetic is when you're adding a constant number.